I know that all of you remember that the Pythagorean theorem is a squared plus b squared equals c squared. Now, I don't know if you remember what the Pythagorean triple is, but we'll talk about that in a moment. It says derive the function that can be used to find the hypotenuse of the right triangle. Okay, so here's a squared, here's b squared, and here's c squared, right? Okay, so we'll just start working, right? So we have x plus 1 squared plus x plus 2 squared is equal to c squared. So let's go ahead and just multiply this out because it says derive the function. Okay, so we've got x squared plus 2x plus 1, that's this thing expanded. And then here we have x squared plus 4x plus 4 is this thing expanded. Okay, so remember we're trying to find c, or the hypotenuse. Okay, so let's add our like terms together. That gives us 2x squared. Here we have our like terms, that's plus 6x. And then here we have plus 5 is equal to c squared. In order to find c, we have to take this value. Now in this case, why are we not taking the positive and the negative option both? Because we cannot have a negative hypotenuse. It's geometry, people. You can't have a negative hypotenuse. That would be like the triangle wouldn't exist. Okay, so that's why we just automatically, we have a positive and negative option here sitting here, but we just eliminate the negative option because of the geometry context of the problem. So our function is, and because we have functional notation, is y equals, or technically even f of x equals that. Julian, I remember you saying the other day you don't like f of x, so this y equals is for you. Okay, so we have 2x squared plus 6x plus 5. All right, now for what value of x is the hypotenuse part of a Pythagorean triple? So this is our first answer here. But what about that Pythagorean triple thing? Well, remember that a Pythagorean triple is basically the 3 values of the right triangle that are all whole numbers, okay? So I'm going to suggest, remember the 3, 4, 5 triangle? Do you remember the 3, 4, 5 triangle? There's also a 5, 12, 13 is a Pythagorean triple. There's quite a few Pythagorean triples, but 3, 4, 5 is the one that's kind of the common one. So if we would say, if we would make this 3, what would we need to have here? If x plus 1 is equal to 3, what would the value of x be? Well, the value of x would equal 2, right? So if we make the value of x 2, then you see how this becomes 3, and then if we have 2 plus 2, that is equal to 4, and then we have our 3, 4, 5 triangle. So if x equals 2, then we have a Pythagorean triple, okay?